All right, this is section 3 of chapter 3, increasing and decreasing functions and the first derivative test. So first off, increasing and decreasing functions. A function is increasing at an interval when, for any two numbers, x1 and x2, in the interval, x1 is less than x2, implies that f of x1 is less than f of x2. Just means if your x values get bigger, your y values get bigger. A function is decreasing at an interval when any two numbers, x1 and x2, in the interval, x1 is less than x2, implies that f of x1 is greater than f of x2. So as you move left to right, your x values get bigger, your y values get smaller. That's what increasing and decreasing means. So the test for increasing and decreasing functions, let f be a function that is continuous on the closed interval a to b and differentiable on the open interval a to b. Notice that that is a condition for pretty much everything we do. It has to be continuous, it has to be differentiable. So first thing, if the derivative is greater than 0 for all x in a to b, then the function is increasing. If the derivative is less than 0, then the function is decreasing. And if the derivative equals 0, then the function is constant. So let's find the open intervals on which f of x equals x cubed minus 3/2 x squared is increasing or decreasing. The first thing we do is figure out where the derivative equals 0. So let's find the derivative. My derivative is 3x squared minus 3x. So to see where that equals 0, I factor out a 3x. I have x minus 1 left. So that is x equals 0 and x equals 1. Those are what we are going to call critical numbers. We've already talked about that in section 1. They are our critical numbers. All right, after we find the critical numbers, we're going to set up what I call test intervals, or what are called test intervals. Basically, make yourself a little number line. Put those two values on there, 0 and 1. Then we're going to plug values in to the derivative, so f prime of x, that are in each of those intervals. Now I don't care what number you choose as long as it's in that interval. So maybe I choose -1, maybe 0.5 here, and maybe 2 here, whatever. All I care about is if the derivative is positive or negative at those points. So if I plug in -1, I get 3 plus 3, which is 6. I get a positive value. If I plug in 0.5, that one's a little trickier. I got to determine this in my calculator. I get -0.75, so it's negative. And then if I plug in 2, I have 12 minus 6, which is still positive. So that means anywhere the derivative is positive, it's increasing, negative is decreasing. So my function is increasing on the interval -∞ to 0, and also 1 to positive infinity. And my function is decreasing when the derivative was negative, which is 0 to 1. And that's all we have to do. So our guidelines for increasing and decreasing. Our function must be continuous. To find the open intervals on which it is increasing and decreasing, we locate the critical numbers, which is set the derivative equal to 0. We determine the sign of f prime of x at one test value in each interval. We pick a number in each interval we made and plug it in. And then we use theorem 3.5 to determine whether the function is increasing or decreasing on each interval, which is just that it's positive or negative. These guidelines are also valid when the interval is replaced by an interval in the form -∞ to b, which we already used. And then we have functions that might be strictly monotonic. That just means that it's increasing or decreasing all the time, never doing the other. So this is the first derivative test. Let c be a critical number of a function, f, that is continuous on an open interval I containing c. Our function is continuous. If f is differentiable on the interval, except possibly at c, then f of c can be classified as follows. So continuous and differentiable. First off, if f prime of x changes from negative to positive at c, then it's a minimum. If f prime of x changes from positive to negative, then f has a maximum. And if f prime of x is positive on both sides or negative on both sides, then it's neither. Basically, that means negative to positive means decreasing to increasing. Oh, look, I have to have a minimum there. Positive to negative means increasing to decreasing. Oh, look, I have to have a maximum. And then let's say increasing flattens out increasing. It's neither. Same thing for decreasing, decreasing. And then I have some pictures there too to show you what I just said. So let's find the relative extrema of this function in the interval 0 to 2 pi. So the first thing we do is find the critical numbers. F prime of x would be 1/2 minus cosine of x. We set that equal to 0. I would add the cosine over to the other side, so cosine equals 1/2. On the interval 0 to 2 pi, where does cosine equal 1/2? Pi over 3 and 5 pi over 3. Now I set up my test intervals. So I like to make a number line here. Put pi over 3 and 5 pi over 3. But also consider the fact that this ends at 0 and starts at 2 pi. You don't want to choose numbers for your test intervals that are outside of that. So let's plug in pi over 6. 1/2 minus the cosine of pi over 6. Well, cosine of pi over 6 is square root 3 over 2. 1/2 minus square root 3 over 2 is a negative number. It's negative. See, between pi over 3 and 5 pi over 3, let's pick pi. 1/2 minus cosine of pi. Cosine of pi is -1. 1/2 minus -1 is a positive value. And between 5 pi over 3 and 2 pi, let's choose 11 pi over 6. And hey, look at that, we get the same thing as we did at pi over 6, so it is negative. Now we are looking for a relative extrema. So my function goes from decreasing to increasing, which means pi over 3 is a minimum. Relative minimum at pi over 3, comma, we'll figure out the y-coordinate in a second. And then it goes from increasing to decreasing, so we have a relative maximum at 5 pi over 3, comma, something. Now we plug those back into the original function to get our coordinates. So 1/2 minus the sine of, 1/2 times pi over 3 minus the sine of pi over 3 is going to give me 1/2 times pi over 3 is pi over 6. The sine of pi over 3 is square root 3 over 2. We'll leave it like that. And at 5 pi over 3, 1/2 times 5 pi over 3 is 5 pi over 6. Minus the sine of 5 pi over 3 is negative, so plus square root 3 over 2. And there we have our answer. All right, for this next one, we're finding the relative extrema, which means we start with the derivative. For this derivative, we have to use the chain rule. So we bring down the power, x squared minus 4, subtract 1 from this power makes it -1/3, times the derivative of the inside, which is 2x. I'm going to clean that up a little bit here. I get 4x over 3 times the cube root of x squared minus 4. There's my derivative. I need to find the critical numbers. And remember, the critical numbers are when the derivative equals 0 or doesn't exist. The derivative doesn't exist when the denominator equals 0. So I need to worry about that. And also when the whole thing equals 0, which is to say that the numerator is equal to 0. Well, the denominator equals 0. Let's see, divide the 3 over and then cube both sides. I still get x squared minus 4 equals 0. That's actually a dozen equals, right? And if I add the 4 over, x squared can't equal 4, which means x cannot equal positive or -2. And then over here we divide the 4, x equals 0. So we have 3 critical numbers, 0, +2, and -2. Put those on my number line in order, and pick a value in each to plug into the derivative, just to determine whether it's positive or negative. So let's see here. Let's try negative 3. I get a negative in the numerator, negative 12, over, let's see, negative 3 squared is 9, minus 4 is positive 5, so it means the denominator is positive. Negative divided by positive is negative. Let's try negative 1. Let's see, I get a negative in the numerator and a negative in the denominator, which means a positive. Let's try positive 1. Positive in the numerator, negative in the denominator, which means it's negative, and positive 3 is positive over positive, which is positive. So we have decreasing to increasing, increasing to decreasing, decreasing to increasing. So we have two relative minimums and a relative maximum. So I have relative minimums at negative 2 comma something that we'll figure out in a second, and positive 2 comma something we'll figure out in a second. And I have a relative maximum at 0 comma something I'll figure out right now. To find these coordinates, remember we plug it into the original. So negative 2 into the original, so x squared minus 4 to the 2/3 power. Well, negative 2 squared is 4. 4 minus 4 is 0. 0 to the 2/3 power is still 0. Positive 2 squared minus 4 to the 2/3 power is 0. And when I plug in 0, I get negative 4 to the 2/3 power, which is the cube root of 16, which we'll leave it at that. And there we have our maxes and mins. And one more problem here. Relative extrema of f of x equals x to the 4th power plus 1 over x squared. We need to use quotient rule to find this derivative. So we take derivative of the top, which is 4x cubed, times the bottom unchanged, minus derivative of the bottom, which is 2x, times the top unchanged, all over the bottom squared. So that derivative is 4x to the 5th power minus 2x to the 5th power minus 2x over x to the 4th power, which is 2x to the 5th power minus 2x over x to the 4th. Now we have to figure out when that equals 0 and when it's undefined. Well, it's undefined when the denominator equals 0. X to the 4th power cannot equal 0, which means x cannot equal 0. When it equals 0, the numerator equals 0. So 2x to the 5th power minus 2x equals 0. Factor out a 2x, I get x to the 4th minus 1. Well, 2x equals 0 gives me x equals 0, which we already said isn't allowed. And x to the 4th power minus 1 gives me x to the 4th power equals 1, which means x is positive or negative 1. So there we have our critical numbers, positive 1, negative 1, and 0. Put them in order on my number line. Pick a number less than negative 1 to plug into the derivative. Let's say negative 2. Let's see, the numerator is going to be negative, the denominator is going to be positive, so it's negative. Negative 0.5, let's use a calculator for this one. 2 times negative 0.5 to the 5th power minus 2 times negative 0.5 all over negative 0.5 to the 4th power, which I know is positive because anything to the 4th power is positive. I get a positive over positive, which is positive. How about positive 0.5? 2 times 0.5 to the 5th power minus 2 times 0.5 is a negative value. Negative over positive is negative. And let's try 2. It's going to be a positive over positive, which is positive. Negative to positive means that it is a minimum. So relative minimum at negative 1 something, and also negative to positive at positive 1 something. And then we go increasing to decreasing, so a relative max at 0 something. Now we plug those in. Negative 1 to the 4th power is 1, plus 1 is 2, over 1, which is 2. Plug in positive 1, I also get 2. Plug in 0, it is undefined. That is not a relative maximum. There is no relative maximum because there's a vertical asymptote at x equals 0.